All right, we're now going to do lesson 8, putting it all together with solving equations. This is just going to be notes. There's not going to be any problems you work on your own. I'm just exposing you or showing you part of what is required in this course, but we're going to do these all together. You're not going to be required to do these on your own. And so we're going to do lesson 8, putting it all together with solving equations. So, what might we see in an equation when we're solving in Math 1? We may see the distributive property to remove parentheses. You've done some of those problems. You may see some variables on both sides in your equations. You may have to combine like terms in your equations. Then you're going to run into two-step equations and one-step equations. But what happens when they all 5 are involved in one problem? Well, the solution to that is to take one step at a time. So we're going to go through this example that is on your sheet. I'd like you to work it out with me. Also on your note sheet are the steps that I will be using to do this with you and to show you how to do this example. So the first thing we're going to do that I have you do is put a line down the middle. So go ahead and put one long line down the middle of the problem. Now it's divided into two sides, and you'll see what I was talking about before. You have some distributive property, parentheses in there. You have some combining like terms. There are variables on both sides. Soon this is going to, after we simplify it, turn into a two-step, then a one-step equation, and then we're going to solve it. But it has everything in it, a lot of little things. So one step at a time. So we're going to focus on simplifying one side at a time. Remember, we talk a lot of times about this being the left side of the equation and this the right side of the equation. So what we want to do is just focus on one side or the other and get it simplified as much as possible. So I'm going to take a piece of paper, and I put it on my screen here. You take a piece of paper, an extra sheet of paper, and just cover up that right-hand side. So what we're going to do is we're going to focus on the left-hand side. So we're going to focus on this left-hand side, and we're going to go ahead, and first thing we're going to do is distribute. And notice the 4 has to be used as a factor to what's inside the parentheses. Now this out here is not in the parentheses, so that 4 does not get multiplied by that 3x out there. We multiply the 4 times the 2x. We multiply the 4 times the 3. But we do not multiply it by this 3x because it was not inside the parentheses. Now we have 4 times 2x, that is 8x. With a 4 times the 3, that's positive 12. And then we have this minus 3x that's part of the problem out here. So then you will see that I have some like terms. 8x minus 3x. That is 5x. And then the plus 12. Now, I can't put 5x and 12 together because 5 has an x on it and 12 doesn't. So what I have done is I've covered up the other side with a piece of paper. I've done any distributing and combining like terms that I see. So I've distributed and combined like terms. So you can see that step is written on yours to simplify the side. Each side is what yours says on your paper. As much as possible by removing parentheses first, then combining like terms. And we did that. So we did that right here. We went all the way down. And we did everything on the left-hand side we could to take parentheses away and to combine like terms. We're also going to do that on the other side. So now you can switch your piece of cover-up paper and cover up the left-hand side, and let's focus only on the right-hand side of the equation. There aren't any parentheses, but there are like terms. So I'm going to put these two together. The 3 and 9 are numbers, constants. They don't have any letters on them. So we have the x, and then the 3 plus 9 is 12. I can't add x and 12 together because 12 doesn't have an x on it. And now I can take up my other sheet of paper, and this is what I can do. Now, I rewrote it for each line so they match up, but it's okay if you come down at the bottom and you write down on the left side what you got when you simplify the left side, and put on the right side what you did when you simplified the right side. So it's okay to bring that down however you wish once it's simplified. Now it says, now just like in the variables on both sides lesson, remove either the x or the 5x to get all the variables on the same side. I told you in my lesson with variables on both sides, I always take the variable on the right hand side, which is a plain x, and take it away. On the left hand side then, I also have to take an x away, because what you do to one side of an equation, you have to do to the other. Now realize that all of this was just simplifying. It wasn't moving side to side. I wasn't doing something. I did simplify one side and I simplified the other side. Now when I take that x away, I'm going to get 4x. Still have the plus 12, and it's equal to 12. Once I've done that and I have 4x plus 12 equals 12, we're down to a two-step equation. All of that mess, we simplified the left side, simplified the right side, and that gets us down to a variable on each side. Move the variable on the right or eliminate it. What I do on the right side, I got to do on the left. Now I want to isolate the term with the x in it. So the opposite of adding 12 is subtracting 12. So over here I'm going to get 4x, and over here I'm going to get 0. And 0 is okay to get. It's not a problem. So we have 4x and we have 0. And now that we've done that, we're down to a one-step equation. So you can see we're down to a one-step equation. Let me fix that. I was trying to underline it. We're down to that one-step equation where all we need to do is to divide both sides by 4, and 0 divided by 4 is 0. So the number that I'm going to put in place of x way up here at the beginning, and both sides are going to balance out to the same thing, is if I change every x to a 0. So all I've done is just followed some simple steps, and I'm going to begin to see what I had in my other problems, and they're going to work out just fine. So here is my, yes, we did it. Now we have x is equal to 0, just like we showed on the other slide. So now we're going to check it. So when I check this problem, what I want to do is I'm going to go in here, and every time I see an x, I want to replace it with a 0. Every time I see an x. So on the left-hand side, this is what I have. I'm going to do what's in here first. 2 times 0 is 0. And 0 plus 3 is 3. So again, I did 2 times 0 first, because I multiply before I add. 0 plus 3 is 3. And so this is what I have. So this is 12 minus 0, which is 12. So this side worked out to 12. Now I'm going to work this side out, and I'm going to change the x to a 0. Then I have plus 3 and plus 9. Well, 0 plus 3 plus 9 is 12. So notice how when I change the x to a 0 on the left side, I get 12 when I do the math. On the right side, when I do the math, I get 12. The equation's balanced. The left and right side will balance out if I change my x to a 0. That means the solution is 0, x is equal to 0, and we've solved this equation. Now I want to remind you that we're going to call this as an exposure lesson. So what we're going to do is you're going to do 2 more examples with me. And there's no work on your own this time. None of these harder problems will be on your quizzes or tests. We just do these examples together, and then we have seen how to do these. You won't run into them that often, so we're not going to focus a lot of our time on them and our energy, and I don't want you to get too frustrated. So all I want you to do is to take this problem and work it out with me. I'm going to put a line down the middle. Now I need to put a piece of paper over. Okay, I didn't have a piece of paper, so I put this black box over my right-hand side so I can work with this left-hand side. So I'm going to distribute on this left-hand side. I'm moving my problem around. So I'm going to distribute. Remember, the 5x is not in the parentheses. So the negative 3 is multiplied by the negative 2x. And the negative 3 is multiplied by the negative 4. But not the 5x because it's not in the parentheses. Distributing is doing the multiplying that factor by what's only in parentheses. Negative 3 times negative 2 is positive 6x. Negative 3 times negative 4 is positive 12. And then we have the 5x. Well, then I want to put together the 6x and the 5x because they are like terms, and that is 11x plus 12. Well, now that is balanced together on the left-hand side. Now I'm going to move my piece of paper over here. That's pretty cool. It didn't really cover it up, but I'm not going to mess with what's in black. I'm going to take care of what's over here. All right, so we're going to distribute, which means we're going to take the factor 3 times that x, and then the factor 3 times the negative 2. Or minus 2. Then we have the 10 that we're not going to do anything with. Remember what we're doing is we're simplifying it by taking away the parentheses and combining any like terms. So this is 3x. This is minus 6. This is plus 10. So that's going to give me 3x plus 4. So now I have 3x plus 4. And I can just get rid of this now. And so now I have simplified the left and right hand side. And what I have left is I have left an equation with variables on both sides. But first I covered up one side, simplified each side separately. Now what I've done in the past and I'll continue to do is to eliminate the x on the right-hand side. So the opposite of 3x is minus 3x. What I do to one side of the equation, I have to do to the other. 11x minus 3x is 8x. Plus 12 equals 4. I'm going to take 12 away from both sides because I'm going to isolate that. So then it's going to be 8x on the left equal to negative 8 on the right. Opposite of multiplying is dividing, so x turns out to be negative 1. And I can check my answer if I want to. I'm not going to go through all of that right now. I'll kind of check it in my head here. So that's positive 2, might as well negative 2, 6, 5. And then the other side negative 4. Okay, let me make sure I didn't make a mistake anywhere. All right, I double checked my work, and I didn't make a mistake anywhere, and I kind of plugged it in my head with using just doing the math in my head just to make sure we were on the right track. You can go through the steps to solve it if you wish, but x is equal to negative 1 is correct. Again, you're only working a couple problems out with me, and so here we go again. I'm going to pause the video for just a second. All right, I'm going to cover up one of the sides. I'm going to cover up the right-hand side. I'm going to do my distributing 4 times the 3x. And then 4 times the negative 1 minus 1. But I'm not going to multiply the 2x by 4 because it's not in the parentheses. This gives me 12x. 4 times negative 1 is negative, or subtract 4 minus 2x. Sorry. 12x minus 2x is 10x. Those are like terms. I've simplified that. And then I want to go back over here, and I'm going to move this over here and make it larger. I'm not going to mess with that right now. I'm going to go to the other side of my equation over here and do 7x plus 11. Well, there's no parentheses, and there's no like terms, so I can't do anything with it. So I'm just going to bring it down here. And then I'm going to get rid of my box. And now I'm ready to do what we did on all the rest. I want to eliminate my variable on the right-hand side. So the opposite's the 7x, to subtract 7x. Put it underneath the 10x, not underneath the 4. There's no x on the 4. There is on the 10. 10 minus 7 is 3x. Take away the 4 is equal to 11. Now I want to isolate the term with the x by doing the opposite of minus 4 to both sides, which is plus 4. The 3x will be isolated. There'll be 15 on the other side. Then I'm going to divide both sides by 3. X is equal to 5. So I'm sorry, I had to kind of switch there. My pen did something weird. So let's see if I can get this to do this. It's messing up. But 15 divided by 3 is 5. So we have 5 for our final answer. Again, I can check my work, and I can see that the left-hand side does work out to the right-hand side. They both work out to 46 on each side, and it does balance. Again, this was a demonstration. Notes only. No work for you to do on your own. Just wanted you to see it, and you can move on to the next lesson. Thank you.